These are the quiz corrections for Math 3 quiz number 12 on sections 4.1 to 4.2. This was taken on January 11th, 2016. Directions: show all your work in the space provided and box your answers. The quiz was out of 40 points. Question number 1. Given each pattern, describe each given pattern. So here I labeled this the first term, this is the second term, and this is the third term. I noticed that each term they're taking away the bottom row. Okay, that's how I described it, because I noticed that there's more boxes and there's less and there's less. Okay. So if you mention something about subtracting, okay, but you have to talk about an entire row. 1b, provide the next two patterns. Well, if I take away this bottom row, then I'm only left with these 4 boxes. And then after that, I only have 1 box, because I would eliminate those 3. Write a numeric sequence. Numeric means a number sequence to represent each given pattern. So I just count up all the boxes here. That's 25, 16. This one is 9. This one becomes 4, and that one becomes 1. Now notice how I have an extra blank here, which means that if I remove this bottom row, or remove that row, there would be no more left, so that would be 0. This is called a finite sequence because there's an ending to it. There's a start and an end. It doesn't keep on going forever. There's no more boxes to eliminate. Each of those were worth 2 points. Notice how these directions in this one says circle 1. Question 2a. Describe each given pattern. This one I said the pattern is adding another column to the left. That's how I described it, or you could have said adding another row to the bottom. For example, there's 1, and then there's 2, and you add another row, that's 3, and the next row has 4. Okay, so very similar to the other problem above. Provide the next 2 in the pattern. So providing means actually, they didn't give me any numbers up here. They're pictures. So you should have drawn them. Remember, if you're confused with what you're asked to do, you can always ask during class or during the quiz. Remember, during the quiz, you should not be asking me a question such as, is this correct, Mr. Ng? You can ask me a clarifying question, but you should not ask for feedback if you're doing the question right or wrong. So my next one is I just add another column. In that case, that one has 5, and this one has 6. If you count them up correctly, you'll have a pattern of 1, 3, 6, 10, 15, and 21. Notice here you're adding 2, then 3, then 4, then 5, then 6, and the next one will be 7. And the reason why this is called an infinite sequence is because that the numbers can keep on increasing forever. That page was out of 16. On the back side, determine if the sequence is, let's just say, a geometric or arithmetic, and the common difference / ratio. 2 points for each blank. So I recognize that when I'm going between each of these numbers that I'm multiplying by a -2. The reason why I see that is because I see it alternating, negative, positive, negative, positive, negative. So -2 times a -2 gives me +4, +4 times -2 gives me -8, -8 times -2 gives me a +16, 16 times -2 gives me a -32. Again, another way you can solve that is what's there on the whiteboard, or taking your second term, 4, and dividing that by your first term. 4 divided by -2 gives you -2. -8 divided by 4 gives you a -2. This sequence is a geometric. It's a geometric because it has the common ratio is -2. So there's all my -2's. Notice how geometric is a second word, and then ratio is also the second word. Remember, you should be doing your quiz corrections over here in this space. Question number 4. The sequence is an arithmetic. It's an arithmetic sequence because the common common difference is -7. Difference means adding or subtracting. So therefore you're subtracting 7 in each of those. Question number 5, write the first 5 terms of the sequence. First term of the sequence is 8, so there you just write an 8 there, and it says d is equal to 12. So d equals 12 means it's a common difference, therefore you shouldn't be adding 12 to each of those. If you missed one, I took off a point, you would get a 3 out of 4. If you missed 2, then I took off 2 points. Here it says the first term of the sequence is -9, and then it says r is equal to -2. Remember, r means geometric, which means you should multiply. Multiplying means multiplying by -2 for the first term. -9 times -2 is 18. 18 times and -2 gives you -36. -36 times -2 gives you positive 72, and 72 times -2 is a -144. And question number 7. This is a Ken-Ken. Same idea with Sudoku. Fill in the blank squares so that each row and each column contain, that should say the numbers 1 to 4. Numbers in cages may repeat as long as they are not in the same row. If you guys haven't seen this pattern, let's see if this works. Now for a 4x4, I started with the freebies. So there's 1. You just write the number 4 there because there's no math operation. And over here with a 1. Let's double check that I'm correct. There's no repeating numbers in this row. Nothing here, nothing there, nothing there. And no repeating numbers in the columns. Now in a 3x3, did you guys see the trick going across diagonally?
Yes.
It had a repeating number, right? But in this case, do we have that?
No.
No. This side was out of 24 points, and 24 and 16 gives you 40 points. This is the right triangles and trig review worksheet. I'm just going to show the answers for the first page and a half because that's just review what we learned before. Notice how you can be using the Pythagorean theorem to solve when you have two sides of a right triangle. That equation is c squared equals a squared plus b squared. This topic about whether it is a triangle, this will not be on your quiz or test. It was an extra credit question because this was an idea we learned last semester. So again, if you want to see these answers or worked out solutions, you can look on the video once I post it. Now, we went over a very difficult concept called special right triangles, and now you can actually solve these problems using trig. So you know it's a special right triangles if you see a 30 and 60, or one of those, in a 90-degree or right angle, or a 45, 45, 90. For example, in question number 9, instead of using the special right triangles equations, you can use cosine. Cosine of 45 degrees equals x over 5 radical 2. That is an option. Or over here, you can use something like sine of 30 equals the opposite over the hypotenuse. Okay? So let me thoroughly go over now the trig part. So trig ratios are short for trigonometric ratios. They're really fractions, and they can be used to find the missing parts of right triangles. There are 3 different types of ratios: sine, which is the opposite over the hypotenuse; cosine, which is the adjacent over the hypotenuse; and tangent, which is the opposite over the adjacent. These fractions are abbreviated by saying a phrase called SOHCAHTOA. In the fractions, the terms mean opposite and adjacent and the hypotenuse, and they refer to the focus angle or the given angle or the reference angle. Number 11. Let's see if I can zoom in. In number 11, I have a triangle with the 55 degrees. This should be your starting point. Circle it, and then you have the opposite side, that's the O, and across the right angle is your H, the hypotenuse, so you have sine. Sine of 55 degrees is equal to the opposite over the hypotenuse. Here you're solving for a side, so you can just put this over 1 and cross multiply. When you do that, you get the equation x equals 48 times sine of 55. Here you have a calculator ready equation. Up here I did give you very specific. It says find the length of each side to the nearest tenth. Tenth means one decimal place to the right. You would have to look at the hundredths, the other one as well. Question number 12. Again, you're going to start at the angle. You're solving for the variable x there. 65 degrees is my starting point. I just need to label my sides. This is the opposite. Notice how this one is the hypotenuse over here, but it's not. It doesn't have a variable or a letter or a number, so I'm not going to use that. Therefore, this side's called the adjacent, which means next to. Now I have these two sides, the opposite and the adjacent, which tells me I'm going to use tangent, O and A and SOHCAHTOA. So tangent of 65 is equal to the opposite over the adjacent. Same thing here, just going to cross multiply, put this over 1. 16 times tangent of 65 is equal to 1 times x, or just x. Here's my calculator equation, and my answer is approximately 34.3 units. This question over here is just asking you to write the trig ratios based off of the letters or the side lengths. Remember, we've been learning that in this diagram you have capital letters and lowercase letters. The capital letters represent angles, and the lowercase letters represent what? They represent sides. So sine of A, you start over here, you're going to the opposite over the hypotenuse. So that would be sides A over C. Again, you're still staying on angle A. Cosine is the adjacent over the hypotenuse, ka, and SOHCAHTOA. So that would be B over C. And tangent is the opposite over the adjacent. That would be A over B. Over here, you're using, in this case, now it changes. Everything, the only thing that stays the same is the hypotenuse, but the opposite and adjacent change. So here you focus at capital letter B. I need the sign, so that would be opposite. It would be B. And the hypotenuse, which is C, B over C. Cosine is the adjacent over the hypotenuse, so that would be A over C. And tangent of B would be opposite over the adjacent. You don't need the hypotenuse. So tangent of B equals B over A. Something we didn't discuss, which is actually skipping section 8.6, is that the trig ratios are exactly the same, A over C and A over C. Sine of A is equal to cosine of B. Those are called complementary angles, but we will not be talking about those. Here is an escalator question. One early escalator built in 1896 rose at an angle of 25 degrees, as shown in the diagram at the right. We actually eliminated the picture to challenge you in drawing one. The vertical lift was 7 feet. Estimate the distance D a person traveled on this escalator. So escalators are commonly found in restaurants, tall buildings, or more popularly in malls, like you want to go to the second floor. So rose at an angle of 25 degrees is basically your angle of elevation. So from the ground and then going up is 25 degrees. Here it says the vertical lift was 7 feet. So vertical, in this case, would be this side. Estimate the distance a person traveled. Well, you're going kind of diagonally, and that is the hypotenuse. So you label it D. So this side is your opposite, and this one is your hypotenuse. Therefore, you use sine. Sine of 25 degrees is equal to 7 over D. Here you can cross multiply. You'll get D times sine of 25 equals 7. This is not a calculator-ready equation because the D is not by itself. So here, I'm going to divide by sine of 25 on both sides. D equals sine of 25 is my calculator-ready equation. If you used your calculator or your trig table to find sine of 25, you'll get 0.423. So if you divide these two numbers, you should get approximately 16.56 feet. Here it doesn't tell me where to round. Notice the given information is a whole number, so you can also say approximately 17 feet. Question number, the water slide problem. The angle of elevation from